Hi, this is David Wagner. I am the designer and creator of Gyro-HPH, which stands for Human Powered Helicopter. And what you are looking at here is blueprint number 1, the main prop overhead view of my 8-wing ducted prop rigid rotor system for a human powered helicopter. I got started on this project by the Sikorsky Human Powered Helicopter Competition in the United States with the American Helicopter Association, and I decided that I could do this. So I started designing and preparing my craft to build a prototype to win the contest. Now, with the aid of this pointer here, I'm going to endeavor to explain to you a little bit of what you're looking at as you look at this strange looking umbrella type prop that I have created for my craft. What we have here in the green, I'll just explain some of the things you're looking at, okay? We see the 8 different sections, which are going to be 8 different prop wings inside of my aircraft prop. Okay, the green is representing here of the one of the individual prop wings. Here is my prop wing main spar. The black is my outer hex ring. The blue here is my inner hex tower. The orange is my transmission tower. The green is my push rod lifting plate, and we'll explain all these things as we go along. Of course, in the center is my main hub, okay, where everything is going to be spinning around. And the aircraft itself is very, very unique. Okay, what we have here in this wing design is a reverse trapezoid wing with the small end of the wing attached here at the center hub. And what this gives us is reverse aeronautics. Okay. Normally on an airplane, if you can picture the main body of an airplane, you would have the main body of an airplane out here, and it would have a wing, and it would go out to the smaller end, just like you see on a Cessna or many other airplanes. Now, if you try to attach the small end of the wing, which is actually where the greatest lift is, on the main body of the plane out here, it wouldn't be able to hold, and it would just rip right off the plane. So what they do is they attach the largest part of the wing next to the fuselage, and where the greatest lift is out here at the wingtip is further on out at the very end of the wing. Now, what I have decided here in my particular aircraft is that I'm going to reverse the aeronautics, and I'm going to flip the wings around, and I'm going to put all the small wingtips here on the inside of my hub. Now, normally if you tried to do that either with an aircraft or an airfoil, or even a helicopter for that matter, by this type of design, you wouldn't be able to do it because it would just rip itself to shreds. The reason why we're going to get away with this reverse aeronautics is because of the material that we are using to build each and every one of the individual props, the material that we're using for our hex towers, and the material that we're using for our outer ring. It's only because we are working with ultra-light materials that this reverse aeronautics is going to take place. So the design of the wing is like having 8 phantom planes whose bodies are represented by the 8 sections which are numbered out here as you go around, and with their wingtips all facing towards this center inner hub. Now, there's a lot of forces that are taking place as we have developed this particular prop wing, and one of them is centrifuge force. Just like when you start spinning something around a central point, the force that is generated starts at the center and goes to the outside. The same thing is going to happen with my prop. In fact, it happens with any prop, is that the centrifugal force is going to start here at the center and move its way from the inside to the outside. Now, because this is our leading edge and our trailing edge of our individual wing, we're going to see that the centrifugal force is going to transfer the power from the center to the outer ring. Now, just like in all aircraft, the greatest amount of lift takes place at the small tip of the wing. There's a great big vortex that takes place here, and that vortex is greatest here, and then it transfers from the inside to the outside. Same with each and every one of my prop wings. They're going to encounter the same type of forces that an airplane wing would. Now, this is the rotation of the prop wing. It is going to rotate in a clockwise motion, and it will spin all 8 of these wings at the same time, which will be lying flat inside of my ducted prop. Now, ducted just means it's an inner circle. It's going to be 6 inches high, and so all of my 8 wing sections will be inside my ducted prop. As the pilot starts pedaling the aircraft, all 8 of these are going to start rotating to a very high RPM. I am doing something entirely different. All the other attempts that have been made have been with very, very large wings, which are well over 50 feet in length, some 75 feet, some even larger, to generate the lift. I am going on the principle that we're going to do something which is smaller and which is moving faster and is changing the aeronautics of what we are doing to create the lift. It's interesting to note, as I have done a history study of Mr. Sikorsky's first helicopter, that his first helicopter that really got off the ground was only 14-foot prop. That's approximately about the size that my prop's going to be. It's going to be under about 13.5 feet by the time we're done. We haven't quite got all the measurements in yet, but it's going to be approximately 13.5 to 14 feet across by the time we're done. So when you understand that the chord length starting here and going to here is 5 feet, the outer width from here to here is 5 feet, the inner width from here to here is 1 foot, the thickness of the wing here is 4 inches here at its greatest part, down to 1.5 inches here, and they all are tapered, of course, towards the wing trailing edge. So that we have a very unique looking prop, wing prop inside the helicopter circle, which is going to lift the craft. Now, because of the unique design of this wing inside of here, we encounter quite a few problems that we're going to have to sort out, which we have already taken care of. Now, on the leading edge, when the wing is simultaneously all turned into the wind, if I can make this my leading edge, the leading edge is going to come up this way. It's going to rotate, okay, from the front to the back, and it's going to engage the air on the leading edge across the full front edge of the wing. But because it's thicker here and thinner here, that means that we have a taper, and we must adjust the wing on the inside. So essentially, if this is my main spar, we have to adjust the inner part of the wing, prop wing main spar has to be adjusted higher on the inside than on the outside, simply to accommodate making sure that the leading edge is going to hit